Hello everyone. Today we're going to look at a topic in organic chemistry called protecting groups. So oftentimes when planning a synthesis of a target molecule, organic chemists must deal with compounds that contain multiple functional groups. Thus, in each step of the synthesis, we have to be very cognizant of how each functional group may react with the reagents we're using. Okay. For example, consider this diol. This has two hydroxy groups, and we want to convert it to a hydroxy ketone. What makes this tricky is that we have two alcohol functional groups, but we want to change only one of them. Right? We want to oxidize this middle one, but not the one on the end. So this is the job for a protecting group. A protecting group is a term for a group that's placed on a molecule through a reaction that temporarily alters the functional group in some way to make it less reactive. So we can then carry out different reactions while that one group is protected as a new, less reactive functional group. Protecting groups then can later be reverted to their original forms at some later point in the synthesis. So in this example, we want to protect this primary alcohol while we later can react the secondary one. Okay, so to protect primary alcohols, we can use isopropylene dissolved in sulfuric acid, which creates a tert-butyl ether, which cannot be oxidized. So now we can go ahead and just oxidize the secondary carbon to a ketone using PCC. And there are some other choices as well that we could use. And our ether is unaffected. Okay. Finally, we could use dilute sulfuric acid, which would then convert that tert-butyl ether back to a primary alcohol. So we're able to oxidize one alcohol while protecting the other. One thing to note is that the protecting group is not fully unreactive. So we do revert it back to an alcohol using dilute acid in the end. So this wouldn't be a useful protecting group if we were planning to conduct a synthesis step in an acidic solution. Another protecting group that we could use is called tert-butyl chlorodimethylsilane, or TBSCl for short. Still not that short, but this reacts in the presence of pyridine to protect primary alcohols as well as secondary alcohols. This can be reverted back to an alcohol using a fluoride ion. Tetrabutyl ammonium fluoride is one organic source of fluoride ions, but there may be others. So this one could be used to protect secondary alcohols as well. It wouldn't have been useful in our previous example because it would have protected both alcohols. So anyway, protecting groups are pretty useful. We'll learn some others, but once you start to get to more complex synthesis problems, you do need to start thinking about how you can protect different groups when needed, what order we would do reactions in, and so on. And that's when the fun really begins. Okay, so if you have any questions, please let me know in Google Classroom or via email. Have a good one.